Welcome to Chapter 20, Part 5. So here we have example 18. A patient must receive a drug 15 milligrams, kilograms times day. The patient weighs 100 kilograms. How many milligrams per day? Well, we have kilograms. So now we have milligrams per day. So all we have to do is multiply 15 times 100, which is 1,500 milligrams per day. And that's our answer. The drug is to be administered in IV piggyback, 200 mLs D5 and over 60 minutes. The vial contains 1.5 grams of the drug in powdered form. Find the IV flow rate in mLs per hour. Alrighty, so we have 15 milligrams per kilogram times day. We know the patient weighs 100 kilograms. Our strength is, looks like we have 200 mLs with 1.5 grams, so that's 1,500 milligrams. And it's going to be done over 1 hour. So one day, we're only administering this for 1 hour. So we have milligrams, milligrams, kilograms, kilograms, day, day. So it looks like we have milliliters per hour. So now I take 15, I'm going to cancel these two zeros with these two zeros. So I have 15 times 200 divided by, well, I could cancel those 15s out. So no surprise that my answer is 200. Alrighty. How many milligrams per minute will the patient receive? Well, we know they're getting 1,500 milligrams in 60 minutes. And that works out to 25 milligrams per minute. All I do is just divide that. In number 19, we have they're receiving 150 milligrams IV piggyback in 200 mLs over 1 hour. The strength is 75 milligrams per ml. How many mLs must be added to the normal saline from the vial? So we have 75 milligrams per ml, milligrams, milligrams, 1, 2. So it looks like we're taking out 2 mLs. So we're putting our 2 mLs into our piggyback. In example 20, the order is for 100 milligrams per m squared. Now we have to find our m squared. Remember the formula for that is, what information do we need? We need our BSA. So our BSA for this problem is 1.65. 1.65 m squared. M squareds cancel out, and we get 165 milligrams. What additional information do you need to compute how many mLs will be added to the IV bag? This drug is available in 60 milligrams per ml. The order indicates the drug should be added to 250 milliliters of normal saline and run at a rate in milliliters per hour should the pump be set. So here we would take we figure out how much we have to add to the IV bag. So we have 165 milligrams we know we need from up here, and our strength is 60 milligrams per ml. So we need 2.75 mLs. So the order indicates the drug should be added to the 250 bag. So 250 mLs plus my 2.75 mLs, and I get 252.75 mLs. We're dividing that by 3 hours. Somewhere I read 3 hours. $252.75 divided by 3 hours, I get 84 mLs per hour. Example 21, I'm going to start with my low range, 2 micrograms per kilogram per minute. The patient weighs 55 kilograms. They're getting 30 mLs per hour. We have a concentrate of 400 milligrams in 500 mLs. So the dose range is 2 micrograms per kilogram per minute to 5 micrograms per kilogram per minute. So I'm going to find out how many mLs per hour they're actually getting, or what the safe range is. So I'm going to start out with my 0.002 milligrams. I just changed this from micrograms. Micrograms to milligrams goes that way. That's how I'm moving my decimal. So 0.002 milligrams per kilogram per times minute, and this is 0.005 milligrams. Oh, this is not going to work. Alright, times 55 kilograms over 1 times our strength, 500 ml, 400 milligrams. Milligrams, milligrams, kilograms, kilograms, mLs per minute. I want mLs per hour because that's what we know our patient's getting. So I'm going to multiply this by 60 minutes times 1 hour. Minutes, minutes. So now I have mLs per hour. do that multiplication, I get 8.25 mLs per hour. Now I'm going to do the same thing, but I'm going to do it for 5. Milligrams times kilograms times minute times 55 kilograms over 1 times 500 ml 400 milligrams times 60 minutes 1 hour. That should be circled. Minutes, kilograms, milligrams. And this gives us 20.625 mLs per hour. Now the patient is getting 30 mLs, which is above the recommended maximum dose for this patient. So this is outside the safe dose. So this is over the max, not safe. And last, we have flow rate. So we have 100 mLs over 60 minutes. They want us to calculate it in drops per minute. Right now we have mLs per minute, but we know that our drop factor is 15 drops per ml. My drops have to go in the numerator, my mLs go in the denominator. And when I do my multiplication, I get 25 drops per minute.